Hello friends, so today we have very interesting topic, optimizing time complexity. So we all have been in a coding interview where interviewer has given us a coding question. So to initially solve the question we use a brute force solution. But once the question is solved, interviewer asks us, can you optimize this? Can you do something better? So we are going to practice exactly how to answer that and how to code that. And for this we are going to solve a very easy lead code question, maximum product of two elements in an array. So this is a very beginner friendly question, so everybody can understand what we are optimizing, and he doesn't need a depth knowledge. So let's straight dive in. So in this question we have to find the indices I and j whose product after subtracting 1 is maximum. So as you can see, there is example 3 4 5 2. So where our answer is index of 4 and 5, so their multiplication after subtracting 1 is 12, so that's the maximum there. So and there are few constraints. First one is the length of nums array is maximum 500, and also the size maximum size of nums of I is till 1000. So we can use int, we don't need a long or anything. So the initial first solution which comes in the mind is trying each option, trying each pair of the numbers and trying to find the maximum of that. Let's start to code that. So you can initialize the iterator I comma j. We can create two loops so we can iterate each pair. I is less than nums dot size. This is the out inner loop which is going to give us a second element in the array. So we also want to take care like I and j can't be same. So if they are same, uh, the indexes are not different indexes as required. So if I is not equals to j, we also need a maximum as a solution. We can initialize it with int minimum, so minimum number possible. And if maximum is less than the product of number after subtracting 1, then we can replace maximum with the new maximum, this value, nums of I minus 1 nums of j minus 1. So max equals to this. And we return the max at the last. So here we have used inner loop and outer loop and able to iterate each pair, and we get the final solution after like updating the max whenever the product is higher than max. So all the text is passed. So as you can see, this is a very slow solution as we are using two loops with nums of size. So the solution, so the time complexity so time complexity is O of n raised to power 2, since we are iterating it 2 times. So this is a brute force solution. So we want to it will ask us to improve this. How we going to do it? So we are going to try to understand the problem itself and trying to find a mathematical way or a solution which will optimize it. So when we go through the solution, we understand we need the maximum number, and the constraint says the numbers are greater than when, so they are all positive. So product of two maximum numbers is maximum. That's a simple logic we have. If we find the two maximum numbers, so here the maximum number is 4 and 5. So as you can see, the result is product of 4 and 5 after subtracting 1. Same goes here. The maximum are 5 and 5. So it's a product of those two numbers after subtracting 1. Same for example 3. So we understand, we are now able to understand the max. If we multiply the maximum number, we get the maximum result. So we can simply fix this by we don't need to initialize anything in this case. We can just sort it. I'm using a predefined function from a vector library. So it would help us to fast track it, and the time complexity of this sort is n log n. You can always write the sorting function, but you have to write the fastest one, and sometimes you don't have a time. So Inter mostly doesn't mind using a sort function. And then we, after sorting it, we could just return the last number. So last two numbers are the maximum two numbers. So last number is the maximum, and second last is the second maximum number. We need the product of those, since we need the product of the largest number in the array. So we could just write nums of size num dot index at num dot size. So last index will be -1, and we can just copy it here to get the second last one. So second last index will be -2, and we subtract 1 from each as required by the solution. This we can just leave it this for now. Yeah, so all test case passed, and it is not top solutions, but we know it could be optimized. I will show you how we can optimize this. So here we're using a sort function, which is taking the maximum time, and the time complexity of sort function is n log n. So current time complexity is n log n. So we have optimized it. If we go here, we can see for n square the trend is worse than the n log n. So we have optimized the solution quite. And if we go for a very large n, if we extend this graph, there is a huge difference. But we can go one step further to O of n, or single iteration here. So for that, we can just write O of n here, which is our final goal. We could create two integers, maximum and second maximum. So we last time we used those, so we only gonna find those, only those elements. So we could initialize these with, I will initialize those. Just give me our time. We can initiate the iterator, initialize the iterator, and so since we have minimum two elements as shown here, so we are going to take the first and the second element, and we are going to assign those value to max and max2. So we have some initial values there. So those could be nums of greater than. So we want to assign the maximum one here. So if nums of 0 is greater, then we assign nums of 0, otherwise nums of 1. We can write this again for max2. Second maximum, we could just reverse this. If 0 is maximum, we assign max2 in that place. After that, we could iterate the whole array to check if any other maximum is there which could replace these initial maximums. So we can, since we have already used the first and second index, we could start the iteration from like literally the third index, but as per array, it's the I equals to 2. We can go to nums dot size, and then if nums dot I is greater than max. So if it is greater than max, then we have to replace max with nums dot I. So maximum always contains the maximum number. But then what? The second maximum will become the third maximum because uh, the second maximum, so the newest maximum is moved to the max. So the number here, we have to move that into second max. So we could do this here, max 2 equals to max. So we are updated if the current number is the highest number. But what if it is second highest number in the array till now? So in that case, if it's not greater than max, but it is greater than max 2, then we can simply replace max 2 with the nums of I. We don't have to do changes in max since it is already less than the max. So after doing this, when the iteration is complete for the array, we have the maximum number in the max and second maximum in the max 2. We have already compared all the numbers with the current maxes, and then we can just return the solution, which will be max of max into max 2 after splitting the 1. So let's run it. So I think uh, yes, okay, I did a mistake here. There should be a question mark. Yes. So all the test cases has passed and time complexity is of n. Since we have done only one iteration, in a single iteration we have found the all top two maximum numbers. So the flow here was how we, as I told, we are going to answer uh, how we are going to optimize it. So initially that was a brute force. We always tried to do a brute force so at least we have a working solution. And after we have a working solution, we try to find a trend in our solution, in our problem. So here the trend was we are going to find the product of the maximum two numbers. Once we find the trend, we can optimize our solution as per the trend. We, after optimizing it with the trend, we got n log n. But once we have done that, we could also try to optimize the code, removing the all the useless code there. So we tried to, since we were at it sorting the whole array which was not required, we only required the max two numbers. So we tried to optimize it in some way that we only run the loop for only those two numbers. So we did that and we got the time complexity of O of n. Thank you. Please don't forget to like, share and subscribe.